So for section 6.8, we're going to be looking at applications of quadratics. So unfortunately for some of you, that means word questions. But the idea is that we're going to look at just some quadratic problems that show up with real world questions. So here's one that's kind of a silly one, but it gives us a good example. What if I knew two boat numbers were consecutive? Okay. Well, consecutive means that one follows the other. So you got these two friends, one's Terry, one's Jody. One has some number, the other one has the next number, and the product of their numbers is 156. So you're just sitting around going, oh, the product of their numbers is 156. Somebody goes, what's the numbers? Go, I've told you enough. You figure them out. Okay? So the fact that they're consecutive means we're going to call the first one that we don't know x, and consecutive means the one that follows it, so that would be x plus one more. Product says I can take these two numbers, this first number x, and multiply it with the second boat number, x plus 1, and it should equal 156. Well, look what we've got. We've got a quadratic equation from a silly example, right? But it still works. Let's see how this works. Remember, for this to work, I need it set equal to 0. Not yet, though, because this left side needs to be distributed out, kind of cleaned up. So now we have x squared plus x is equal to 156. To get it set equal to 0, we're going to move the 156 over so that we have x squared plus x minus 156 equals 0. Now we're ready to solve this. We are going to factor this. What multiplies to make x squared is x times x. Second, I need a product of 156 that combines to make 1. Well, that would be 1 and 156, 2 and 80, nope, how about 78? Obviously, I'm going to need to go way further because I need like things that are 1 apart here. 3, 52. Please feel free to use your calculator on this. 4 and 44. We picked the most freaking number that has the most factors ever. At least 5 doesn't go in, but 6? No, 6 goes in. 6 and 26. We're getting closer though. 7, 8. 8 goes in. 8 and 22. At least 9 doesn't go in. 10, 11, 12. Check it. 12 goes in there. 12 and 13. Ding, 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 ding. We finally found it. Numbers that are 1 away, right, that multiply to make 156. To make it a positive x, that would need to be a positive 13 and a negative 12. Okay? So, take each group, set them equal to, and we get that x is equal to negative 13, or x is equal to 12. Well, this begs a question. Are both these right? Remember, these are boat numbers. Which of these doesn't make sense? Is there going to be somebody with a boat number of negative 13? So probably not. So chances are the only answer we would keep here would be the 12. This other answer that doesn't make sense, we have a word for that. It's called extraneous. Mathematically, we got that answer, but chances are the guy's boat number is not negative 13, unless they're like really geeky math people. So I'm going to say the first person's boat is 12, and the next consecutive number, the next boat number would be 13. So to go back up to the top, Terry's number is 12, Jody's number is boat 13. If they were really geeky, Terry's number could be, what would it be, negative 12, and then this one would be negative 13, but probably not, okay? All right. Your desk is a 800 meter square area with a length twice as long as the width. What are the dimensions? You're like, I don't know, pull out a ruler, right? Okay. But here's what we're going to do. draw this rectangle. This is a desk. We know that it has an area of 800 square meters. We do not know the length and the width, right? But I do know, and let me be clear, because this could be an interesting question. They're going to make the numbers nice, but I may know the area, but I'm going to look at that, and maybe the dimensions aren't even whole numbers. And so maybe I couldn't measure it with a ruler. So this algebra would actually get us an exact solution. Yeah, whatever. All right. So what we do here is we take the two things, the width and the length, and we figure out which one we're comparing to. The way we figure that is they'll have this word like as. As the width says that that width is my variable. Well, what is the length? Well, the length is twice as long as the width. So it's two widths. So I find that kind of comparing word, and that becomes my variable. And then the second one, I'm not going to put it as a second variable. I'm going to call the length 2w. Why do I want that? Remember, the idea here is it's easier to have one variable than to have two. So how are we going to solve this now? Well, I'm going to go ahead and say the area of a rectangle is length times width. So the area of this rectangle, which they give us, 800 square meters, is equal to the length of the rectangle, which I'm not going to put L, I'm going to put 2W, times the width, which is also W. So I get 800 is equal to 2W squared. So you got a couple options. I can set this equal to 0 and factor it, but the best thing that I see off the top of my head is that everything is divisible by 2. That makes our lives a lot easier. So instead of dealing with the 800, we have 400 is equal to W squared. I could move the 400 over and factor if you did that. Okay, so if I did this by factoring, I would have W squared minus 400 set equal to 0. So I'd move the 400 over. I would then have to factor this. I would have to recognize that it's an a squared minus b squared, so that what multiplies to make 400 and makes 0 in the middle would be a positive 20 and a negative 20. And then I would get, by setting each group equal to 0, I would get that W equals negative 20 and W equals 20. That's one option. Or, like I said, since there's a single W, I can do inverse operations on this to undo a second power. I would use a second root and get that W is equal to the square root of 400 is 20, and we would still have the plus or minus. Both answers, plus 20 and negative 20. Once again, which of these answers would be extraneous? Well, chances are I don't have this interdimensional desk that is negative 20 meters, right? So our width must be 20, which means our length would be twice as much, 40. So our width would be 20, and our length would be twice as much, 40. And the area, just to check, would be length times width, 40 times 20, or 800 square centimeters. Last one, and I think this one's probably the most interesting. They have these leaves, and I think they have these in South Africa. The book actually has a picture of it, or you can look at the e-edition of the book and see a picture of it. But they got these leaves that are like the size of people's arms. So what if they could see that that leaf was approximately 320 square inches, and that they know that the length is 12 inches longer than its width? What are the dimensions of this leaf? Well, I say estimate it or approximate using a triangle. They're like, well, we got a leaf. So we're like, it's a red leaf. Okay, fine. Here, now it's a green leaf. Leave me alone. Okay. So here we got this leaf. Okay. And the idea is that we say, I know the area of this leaf, and isn't this leaf approximately the shape of a triangle? No, it's not perfect, But could we get some approximate dimensions if we know that it's approximately the shape of a triangle? Yes, we can. Once again, the area of a triangle is 1/2 length times width. I know the area. I don't know the length or the width. Where's our comparing word? As a length that is 12 inches longer than, there's my comparing word, it's the width is W. The length is 12 inches longer than W. So how about W plus 12? Why do I do this? This is way easier to solve with one variable than it is with two. So we start filling it in. What's the area of the triangle? 320 is equal to 1/2 the length, which is W plus 12, times the width, which is just W. We can distribute this out. 320 is equal to, I would multiply the W backwards. I know that's going to make some people uncomfortable. So I'm going to start by just multiplying the 1/2 in. And get 1/2 W plus 1/2 of 12 is 6. Still all times W. So now I'm going to sit there and take all that, and I can distribute it like this if that makes you feel better. Once again, I would just distribute backwards. Doesn't really matter. Either way, we get 320 is equal to 1/2 of W squared plus 6W. If you don't like this fraction, you could have taken care of this a long time ago, but if you don't like it, and we're going to have to deal with it now, take everything and multiply it by the denominator, by 2. That makes that first number 640. That makes 1/2 times 2 is just W squared, and then makes that 6 into a 12. How do I solve this now? Well, it's a quadratic. Set it equal to 0. So we get, I'm going to bring this up here for space-wise, 0 is equal to, how about W squared plus 12W minus 640. This is ready to factor. Alright, I'll work on my arrows here. Alright, so what's going to multiply to make W squared is W times W. Second, I need something that multiplies to make 640 and combines to make 12. Chances are we're not coming up with that at the top of our head. This is where a t-table comes in handy. I'm going to list the 640, and if I can't come up with it, I'm just going to start throwing out numbers, starting with 1. Obviously, that's not 12 between them, but this is just a pattern to get them all. 2, 3, good news doesn't go in. 4, 160, 5, 128, 6 doesn't go in, 7, 8 goes in, 9 does not, 10 does, 10 and 64, 11 does not, 12, I don't think 12 goes in, 48, 60, no, it doesn't go in. Like I said, you should have the technology, check with your calculator. 13, 14 doesn't go in, 15, 16, 17, 18, 19. I think the next one that goes in is, oh crap, did 16 go in? Yeah, what is that, 16 times 40? Still not 12. 17, 18 doesn't go in, 19, but 20 does, 20 and 32. And I could keep going, but I hear some ding, 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 because there's a 12 between those. So it would be a 20 and a 32, and to make it positive 12, and negative 20, and a positive 32. Whew. A lot of work. What do we do now? Take each group, set them equal to, take each group, set them equal to, so that we get that W is equal to positive 20 or W is equal to negative 32. Which of these is extraneous? you are not going to have a leaf that is negative 32 inches. That makes no sense. So the width in this situation is 20. So let's see. If the width is 20, then what is the length? 20 plus 12, or 32. There shouldn't be that many questions here. I know they're kind of tough, but muscle through them. It's just going to show us different applications. I think out of the three that this is kind of the most interesting. We have more interesting ones as we get in more advanced mathematics, but for now, this is what we get to deal with. So just know that these quadratics aren't just for fun and giggles. They have a purpose. We do actually solve questions with these all the time. And it's just kind of giving you a taste of that.